All right, so in the third part of this problem, we're going to let the elevator accelerate upward at 2.2 meters per second. So we have this screw in the elevator. While the elevator is moving at this speed and accelerating at this rate, screw falls off. And what we're going to do is have someone on the ground observe this. And that person on the ground is going to calculate when that screw hits the elevator floor. So again, like in the first part of the video, what I want is I want the position of the elevator floor equal to the position of the screw. I want those positions to be equal to each other. So I need to write an equation for the elevator floor. According to this person, the elevator floor is originally, we'll call it y naught. We'll say that the elevator floor is originally a distance y naught above the observer or above the ground. Okay. And it starts moving upward, and it's moving upward at this rate and it's accelerating. So again, the floor of the elevator is moving with constant acceleration. So y floor is going to be equal to the initial position plus the initial velocity times time, and then plus your 1/2 at squared term. So now, this is the position of the elevator floor. What about the screw? Of course, the screw is undergoing constant acceleration. But now be careful, because the screw is not loses contact with the elevator, it's free falling, so its acceleration is minus 9.8 meters per second squared. Again, we're defining down as negative. And so the initial position of the screw is 3 meters above the elevator floor. That's what the velocity was of the elevator and the screw when the screw came loose. And now the screw is free falling. And so we set these two equations equal to each other. Because we want to set y floor equals y screw. By the way, a half of 2.2 is 1.1. And we do get cancellation in this problem. Y naught cancels. The 2.2 t cancels. And we're left with 1.1 meters per second squared t squared equals 3 minus 4.90 meters per second squared t squared. And if I move this 4.9 to the other side, you can easily see, and I didn't put the units here, sorry. You can easily see that the time that you get is 1 over root 2. Okay, so this is the problem involving the case where the elevator is actually accelerating upward. Okay. Again, remember that once the screw loses contact with the elevator, it's free falling. But when it came loose, it was moving with the elevator. So its initial velocity was that. But after it comes loose, its acceleration is 9.8 meters per second squared.